Hi everyone, I'm David from Edge Impulse, and in this video series, I'm going to highlight and show you how to use the Thundercomm Rubik Pi 3 with Edge Impulse for quick and easy model creation and deployment for your Edge AI projects. This will be a multi-week series covering hardware, software, use cases, example projects, and more. This is the first video in the series, so we'll start off with the hardware specs, the software ecosystem, and cover the kinds of projects you can build with the device. From there, I'll introduce computer vision and show you how to run object detection on the board with Edge Impulse. Let's get started. At the heart of the Rubik Pi 3 is the Qualcomm QCS6490. This is an 8-core processor designed for high-performance IoT and Edge AI applications. There are 4 Cryo Cortex A78 high-performance cores and 4 lower-power but more efficient Cortex A55 cores, an Adreno GPU, and a Hexagon NPU that offers 12 TOPS of AI acceleration. It comes with 8 gigs of RAM and 128 gigs of UFS storage, which is integrated high-speed flash storage. There's also an M.2 slot for an NVMe SSD if you need more space. Connectivity is great with gigabit Ethernet, Wi-Fi, and Bluetooth, as well as HDMI for 4K displays, USB-C, and 2 MIPI CSI ports for cameras. The dual camera support is nice for stereo vision or multi-angle imaging applications. There's also a 40-pin Raspberry Pi compatible GPIO header, so you can use many of the hats and accessories from that ecosystem as well. Now, let's talk software. The Rubik Pi 3 supports several operating systems, including Qualcomm Linux, which is based on Yocto and is meant for production workloads, but a native, optimized build of Ubuntu is also available for the Rubik Pi and can easily be installed directly on the onboard storage. There are also Debian and even Android builds available if you need those instead. For developers, the workflow is familiar to any other single-board computer. You simply plug it in and turn it on. Then you can use VS Code to connect to the board remotely, build and deploy containerized apps, run Python, install Node, or any other typical workloads. Or you can hook up a keyboard, monitor, and mouse and work on it locally, like a Jetson Orin or a Raspberry Pi. And, like I'll show you in a moment, it works with Edge Impulse, so you can train a model and deploy it directly to the board. So, what can you build with the Rubik Pi 3? For computer vision, the onboard NPU and dual camera ports make it ideal for smart cameras, object detection, automated defect inspection, counting tasks, anything that needs fast, local inference. For robotics, the CPU and GPU combo gives you excellent performance for navigation, control loops, or gesture recognition. It's great for drones, robotic arms, and mobile autonomous robots. For IoT and smart devices, it can act as a central controller for gateways, appliances, access control systems, or voice-enabled devices. It even has enough power to run small language models or even SVLMs on device, which can allow you to build local AI assistants that don't rely on the cloud or need any connectivity. But we'll cover audio, robotics, and other topics in future videos in this series, though. So for now, let's focus on computer vision. To get started with computer vision on the Rubik Pi, let's go to Edge Impulse and log in. I'll show you how to build an object detection project today, but like I mentioned, we'll cover audio and sensor data in future videos, so be sure to check those out once they're ready as well. First, I'll go to studio.edgeimpulse.com and log in. Then I'll create a new project, give it a name. Personal and public will be absolutely fine here, and I'll click Create Project. In order to build a model, I need to first collect data. So I'll click this button here, Collect New Data. I'll scan the QR code on my phone, open up the project in the phone browser, and I can start taking pictures. I'm going to use these miniature concrete blocks today, which are great for testing. As I take pictures with my phone, the images will upload directly into my project here. Okay, So I took about 100 pictures of my blocks, which is plenty to get started with. Next, we'll need to label our data, which in the case of object detection means drawing bounding boxes around our concrete blocks so that the model can learn what we're interested in. I'll click on Labeling Queue, and I can simply draw a box around the concrete block and give it a label. I'll repeat this for all of the images in the dataset, but as you can see, the bounding box will follow along from image to image, making it a quick task. Next, I'll build my impulse, which is the machine learning pipeline. I'll click on Impulse on the left. The first column is pre-populated for me, though I will bump the input resolution to 320 by 320, and then I need to add a processing and a learning block. I'll choose Image for processing and Object detection for learning. The output features should auto-populate, and then click on Save Impulse. Next, click on Image on the left to choose between color and black and white feature extraction, and then click on Save Parameters. On the Generate Features page, click the Generate Features button to build out a visual representation of those processed features, which will be our first indication of how well our data is clustered. On the left, let's click on Object Detection, and here we can train our model. I'll leave the default settings as is, but there are lots of parameters and even an expert mode to help you get the most from your model. When you're ready, click on Save and Train to start training. On the right-hand side, you'll see the progress, and at the end of the training, you'll get a confirmation that it completed and be able to see the precision score or accuracy, which is measured against validation data. Finally, click on Deployment on the left, and in the search field, start typing Qualcomm and choose Linux AArch64 with Qualcomm QNN. Also be sure to select Quantized int8, which is needed by the Hexagon NPU, and then click Build. This will compile and download the model to your laptop or desktop computer, but we're actually going to hop over to our Rubik Pi now and just download the model directly there. Okay, so I've connected to my Rubik Pi, and I need just a few quick steps to prepare the board to run my concrete block detector. This Rubik Pi is running Ubuntu, but if yours is running Qualcomm Linux or another OS and you want to switch to Ubuntu, you can check out the documentation at rubikpi.ai to go through the flashing process. But here on Ubuntu, I'll run a sudo apt-get install libqnn-dev just to make sure I have Hexagon NPU acceleration available, and then I'll follow the instructions in the Edge Impulse docs to install the Linux runner, which is only a few commands. Once installed, I can launch Edge Impulse Linux Runner, and I'll be asked to log into my Edge Impulse account, choose a project, and then our model will download and inference will begin. I'll launch a browser, go to localhost 4912, and sure enough, we can see that our custom object detection model is running and working great. So hopefully this video gave you a good overview of the Rubik Pi 3 and its features and capabilities. You can buy the board on many of the popular hardware vendor sites such as Arrow, Codico, Atlantic, and others as well. It's listed at $99 USD, which is a great price for the performance and software stack that you get. And as I showed in this video, it's fully supported by Edge Impulse for running on-device AI, making it great for robotics, smart home, industrial automation, and other use cases where local AI is needed. In the next video, I'll show you how to build audio projects like keyword spotting, so be sure to check that one out if audio classification is what you're in need of. Thanks for watching, and I'll see you in the next one.